In this lesson, we're going to solve some application problems that end up having a quadratic equation to solve. You can't necessarily tell that they're going to be quadratic equations until you set up the equation, simplify, and you'll see that you have an x squared. In example number 1, we have the length of a rectangular garden is 5 feet longer than twice the width. So we're dealing with our rectangle, and I'm going to let my width be x, and my length is 5 feet longer than twice the width. So it's 2x plus 5. But instead of it being a perimeter problem, we're going to talk about the area is 462 square feet. Find the dimensions. Well, area of a rectangle is length times width. So my area, we know, is 462 square feet. And my length is going to be 2x plus 5. My width is going to be x. So I have 2x plus 5 times, I'll put the x out front, equals 462. So you'll notice that when I distribute here, I end up with a quadratic equation. So now we have to say, okay, this is quadratic. I have my x squared, and I have an x, and so the first step is to set it equal to 0. Now I need to decide what method of solving quadratic equations do I want to use. Well, you have a 2x squared here, which makes factoring a little bit difficult, and completing the square. You have an x and an x squared, so the square root property is not going to work. So I'm going to go with the quadratic formula. So I have my a is 2, my b is 5, and my c is negative 462. So I end up with x equals negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 462 all over 2 times 2. And if I do some simplifying here, get negative 5 plus or minus the square root, I'm going to do some of the simplifying all together. I get 3,721 all over 4. Since this is an application problem, I really want an approximate answer to this problem, not an exact answer. So I'm not even going to worry about trying to simplify the square root of 3721. I'm going to just put it into my calculator. Now remember, what I have here is x equals negative 5 plus the square root of 3721 divided by 4, and x equals negative 5 minus that. Those are going to be my two solutions. Using my calculator, I'm going to get x equals 14 and x equals negative 16.5. Since this is an application problem and x represents width, I obviously can't have a negative 16.5. So my width is going to be 14, and this would be my width, and my length is then going to be 2 times 14 plus 5, which ends up giving me 33. And we're looking at feet and feet. Can I verify my answer on this one? Sure, I can take 14 times 33, and that should equal 462, and it does. So I know for sure that these two answers are correct. In the next example, I have a cost function for a certain company is C equals 20x plus 220, and the revenue is R equals 60x minus 0.5x squared. Approximate a value of x that gives a profit of $500. Now, I need to make sure I know this formula, profit equals revenue minus cost. So if I set this up, I'm going to have my profit, which is 500, and then I have my revenue and I have my cost. So I'm going to have 500 equals 60x minus 0.5x squared minus 20x plus 220. You'll notice I put my parentheses for my revenue and my cost because I need to subtract the whole cost from the revenue. So what am I going to have to end up doing? I'm going to end up having to distribute this negative, and that's probably the most common mistake. And so when I simplify this down, I'm going to rewrite it so it's in kind of standard form, not set equal to 0 yet, I end up getting this. So I'm going to set it equal to 0, and I have 0 equals negative 0.5x squared plus 40x minus 720. Now at this point, I can use the quadratic formula, and I'm going to do that first, and then I'm going to show you how we actually can complete the square with a little manipulation of that equation. But let's use our quadratic formula. A equals negative 0.5, B equals 40, C equals negative 720. So I end up with x equals negative 40 plus or minus the square root of negative 40 squared minus 4 times negative 0.5 times negative 720 all over 2 times negative 0.5. So I get x equals, once again, I'm going to do a lot of this simplification on my calculator. And I get the square root of 160 here, and this will be negative 1. So once again, I'm just going to use this on my calculator. I'm going to write this as 40 plus or minus the square root of 160. Just get rid of that negative 1 in the denominator. Put that into my calculator, and I'll get x equals 52.65 and 27.35. You'll notice both of these answers are positive. Both of them are possible values of x, which basically means the cost of an item. So I need to check both of them. For my first problem, I'm going to say my cost is 20 times 52.65 plus 220, which gives me 1273, and my revenue is going to be 60 times 52.65 minus 0.5 times 52.65 squared. I get 1773, and you'll notice the difference between these two equals $500, which is exactly what I wanted. Now I'm going to let you go and check the second solution, and you'll see that you'll also get a value that actually works. It is possible to come up with two solutions even on application problems. Okay, I want to go over another way to solve this problem. At this point right here, I could take and divide everything by negative 0.5. And it's going to happen to work out because that's going to go into these numbers evenly. And I'm going to end up having this equation. Okay, so when I look at this, you'll see that I have a 1x squared, and I have my b is even, so I can actually complete the square. So I just want to show you how I can do this probably a little bit faster completing the square. When I complete the square, I'm going to write it like this, and I'm going to look at what I have to add to both sides to make this so I can have something squared equals a number. Okay, so remember, we take that negative 80 divided by 2 squared, and we're going to add that to both sides, and that is going to be 1600. So when I do that, this is going to factor as x minus 40 quantity squared, and then when I add these two, I end up getting 160. You'll notice that 160 showed up using the quadratic formula. But now I can use the square root property and just get x minus 40 equals plus or minus the square root of 160, so x equals 40 plus or minus the square root of 160. It's actually a lot faster than using the quadratic formula, but you have to understand how to complete the square and see that it is something when I divide by negative 0.5, I get something that's actually easy to complete the square. Okay, in this last example, we have a ball is dropped from 288 feet above the ground. How long does it take to reach ground level, or to reach 100 feet above ground? So in this case, we need to use this formula where the height after t seconds is h equals negative 16t squared plus h naught, where h naught is our initial height above ground. If you get a problem like this on a quiz or an exam, I will definitely give you the formula. You just need to use the formula. So this is one of the easier types of problems because you have the formula right there for you. So in this case, It's 288 feet above ground, so that means our H naught is 288. And I want to figure out how long it takes to reach ground level. So what would be my ground level? What would be my height after t seconds? If it's at the ground, my height's going to be 0. So I just have to set 0 equals negative 16t squared plus 288. Now you'll notice something about this quadratic equation. I have a t squared, but I don't have a t. So this is a perfect type of problem to use our square root property. I'm going to get the t squared by itself. I get t squared equals 18, so t equals plus or minus the square root of 18. Okay. Once again, this is an application problem, so I'm just going to put this into my calculator, and I get t equals plus or minus 4.24. Okay. T represents time in seconds, and so if I look at this answer, my only possible answer would be 4.24, not the negative, seconds. Okay, and I can go and check this by plugging it in and make sure that when I take negative 16 times 4.24 squared plus 288 and put that into my calculator, I end up with 0.3584, which is very close to 0. For the second question, they want to know when it'll be 100 feet above ground. So in this case, my h is 100, and I'm going to have 100 equals negative 16t squared plus 288. And I still only have a t squared and no t. So I can still use my square root property. I need to subtract the 288 from both sides. Divide by negative 16. And then take the square root. And then take the square root. And I get t is approximately plus or minus 3.43. But once again, I'm looking at seconds, so t is approximately 3.43 seconds. So you can check this solution the same way we did above and verify that it's correct. The one thing I want to mention is I think the most difficult part about these application problems is recognizing that they are actually quadratic and then deciding which method of solving for quadratic equations you're going to use. The quadratic formula is a good method for most of these because you are approximating your solutions. So it really doesn't matter how messy it is, you can use your calculator and come up with those approximations.